Okay, so you don't always want to just jump in and try and solve directly for t. In fact, here's an example where we actually don't want to go that far. Since both of these expressions involve the variable expression square root of t, it makes no sense to go all the way back to t. I can just take this top first equation, x equals square root of t plus 4, and I can just solve that for square root of t, right? By realizing I can just bring the 4 over and say that square root of t can be replaced with x minus 4. I also could have solved for square root of t here, but that would have brought a fraction in, and I'd prefer this alternative way. So since square root of t is equal to x minus 4, we could keep going and saying, well, now y is 3 times that. So 3 times x minus 4. So y is equal to 3x minus 12. So the graph is actually going to be a straight line, even though both equations are involving square roots of t. So this is going to actually be a straight line. And once again, we want to compute a few points at least your first and last. And again, if you want to add a middle point in there, to kind of, fill things out a little more, that's perfectly fine. So t is ranging from 0 to 16. So if I plug in 0, that would be square root of 0 plus 4 would be 4. 3 times square root of 0 would be 0. And this time, since it's a straight line, I'm just going to go ahead and plug in the last point. 16. Square root of 16 is 4, plus 4 would be 8. And here, 3 times the square root of 16, 3 times 4 would be 12. Okay? So again, remember, this is a straight line because the equation there. 3x minus 12 is a straight line. So the 2 points is more than enough. Not only will it give me the graph, the portion of the graph I need, it will also show me the direction as well. So my first point is the point 4, 0. So I'm just going to come over here, mark that as 4, 4, 0. The next point was 8, 12. So I'm going to come over here, 8. And then we're going to go up 12. So my second point here on the line would be 8, 12. So the graph is starting at my first point, continuing to the second point. So of course, the direction of motion would be from the first point to the second point. Okay. So here we have our graph and we have our orientation. Right. Again, we know that it's in terms of the graph 3x minus 12, but it's only the part that ranges from x equals 4, 0, x and y is 4, 0 over to the point 8, 12. Okay. All right. So let's stop here on this example, and we're going to look at a few more where we don't always want to try and solve directly for t. We don't always want to try and solve directly for t. And we'll see an example in our next video where that's the case.